5.2 is on page 276. It talks about the characteristic equation. That's a very important section. Lambda is an eigenvalue of a square matrix if A times x equal lambda x. We find the eigenvalue by solving this equation, or easier, this equation. Since x cannot be 0, it must be that A minus lambda I equals 0. Satisfy the equation ax equal lambda x. It's sufficient to take the determinant of A minus lambda I set it equal to 0 to find lambda, which is the eigenvalues. The characteristic equation is what we're interested in. Characteristic polynomial is just the determinant of A minus lambda I, but the characteristic equation is really how we're going to find our solutions. And we start off on page 281 with two examples. It says find the characteristic polynomial and eigenvalues of the matrix. Well, we really start with, and something we're going to do for now, it's going to look awkward, but we're going to be doing this for some time now. So if I take the determinant of A minus lambda I, I'm going to write them out in the beginning. That is the determinant of A minus lambda times I. Well, I is 1, 0, 0, 1, so that's lambda 0, 0, lambda. And if you subtract those, that's simply 5 minus lambda 3, 3, 5 minus lambda. Set that determinant equal to 0, and that would be simply 5 minus lambda squared minus 9 equals 0. 5 minus lambda squared equal 3. 5 minus lambda equals, okay, you know what I'm thinking, right? Equals 9, square root both sides. And then lambda will equal 5, so swap those. Minus plus 3, lambda will equal a 2 or an 8. And there it is. That's pretty much how we do it. You can do it the way you want, but this turns out to be very efficient and to the point. And if I look at problem number 4, debating how I should do this, probably my best bet is to put them all side by side and do them all one shot. So probably I'm better off keeping this underneath. This way I could shrink this a bit and plan this accordingly. Alright, so, and if I do the same here, if I find the characteristic polynomial, there it is, and the eigenvalues, well, I'll take minus, again, lambda I. That would be the determinant. Remember the determinant, how that goes. 5 minus lambda and negative 3, negative 4, and 3 minus lambda. Set that equal to 0, and that's going to be, if I multiply lambda squared minus 8 lambda plus 15 minus 12 equal to 0, lambda squared minus 8 lambda plus 3 equal to 0, lambda squared minus 8 lambda. Take half of the middle number, which is 4, and square it. And I get lambda minus 4 squared equaling 13. So lambda will equal 4 plus or minus radical 13. Those are the two distinct values of lambda. And if I work number 6 out, the same thing, minus lambda I, well, that's lambda 0, 0, lambda, right? If I want to find A minus lambda I, and then take the determinant of that. So determinant of A minus lambda I equaling to 0, that would be 3 minus lambda and negative 4, 4, 8 minus lambda equaling 0. That would be 24 minus 11 lambda plus lambda squared minus plus 16 equal to 0. So that's lambda squared minus 11 lambda plus 40, right? equal to 0. So lambda squared minus 11 lambda plus equal negative 40 plus half of the middle number 11 squared 121 over 4 121 over 4 lambda minus 11 halves squared equaling over 4 negative 160. That is negative 160 minus 121. So 40, 39, negative 39, so there's no solution. We don't really take complex solutions yet. That's coming up. And if I take the last problem, and I take the determinant, and I do want to set up and talk about what does it mean to have the characteristic polynomial. Find the characteristic polynomial that's actually right there. That equation. Or that polynomial, actually, right there. Right, that's easier. And the characteristic polynomial is simply you figuring out, again, if I do this minus, and pretty soon I'm going to stop writing this part and just jump to this right here automatically. 7 minus lambda negative 2, 2, 3 minus lambda. Set that equal to 0. That is 21 minus 10 lambda plus lambda squared minus 4. And that would be lambda squared minus 10 lambda plus 17. That is the characteristic polynomial right there. I'm going to set that equal to 0 and solve. Right? And lambda squared minus 10 lambda. Take half of the middle number, which is 5, and square it. And I'll get lambda minus 5 squared equaling 25. That's an 8. So lambda is going to equal 5 plus or minus 2 radical 2, if I'm not mistaken. I am mistaken. That was a plus 4. My mistake. So again, I was wondering, because we're supposed to get all different combinations, and I was talk about those once we get them. So that is lambda squared minus 10 lambda. I could say this is the characteristic polynomial. I don't want to mix you up with the 0. There it is. So plus 25, set it equal to 0. That's lambda minus 5 squared equal to 0. That's lambda equal 5. Multiplicity 2. So if I was going to ask you what are the possible outcomes of a quadratic, well, if it's a 2 by 2, the quadratic solution could have 1 repeated root, 2 distinct roots, or 2 complex roots. And that's about it. Those are all the possibilities that we can get. Now, find the characteristic polynomial for each polynomial. Use either cofactors. Okay, whatever that is. We're not really concerned with that. We know how to do this already. And I have 2 more to go. So this is, we're crunching this, figuring out the characteristic equation minus lambda I, that's lambda 0, 0, 0, 0, lambda 0, 0, and lambda. Lambda across the diagonal, and all the other entries are 0. So if I set the determinant here, I'm really talking about lambda 3, 1, 3, oh, negative lambda, 2, and 1, 2, negative lambda. And if I want to find the determinant of this, there are many ways I could do that, and I really don't mind how you do it. I'm going to take negative lambda 3, 3, negative lambda 1, 2, and I'm going to go by the product of those 3 using the shortcut. That is lambda cubed negative plus 6 plus 6 minus, nope, I messed up. So that's why you should line them up properly. That would be a negative lambda minus 4 lambda minus 9 lambda. And that's a determinant. That's negative lambda cubed plus 12 plus 9, 10, 14 lambda equals 0. That's really negative lambda cubed plus 14 lambda plus, oh, I'm sorry. It says, technique 3.1, find the characteristic polynomial of each matrix. Use either cofactors or 3 by 3, right? It says in 15 through 18, oh, you know what? In 15 through 18, find the characteristic polynomial. It's not easy to do so without row operations because lambda is involved. Alright, that's not a problem. It's all the same. I don't know why I copied those directions. Oh, describe prior to 15 through 18. Okay, I get it. I'm sorry. So, there's the characteristic equation. If they wanted the lambdas, we know how to do that. And if you recall, the factors of 12 would be a possible rational zeros. You try that using the rational zero theorem from back in college algebra when you graph polynomials. How about this problem? Well, I'm going to jump straight to it. To figure out the characteristic equation, a minus lambda I equal to 0, well, that is what? That is negative 1 minus lambda 0, 1, negative 3, 0, 4 minus lambda 1, 0, and 2 minus lambda. Now, here I would also use, you know what, probably here I'm better off. I'll just pick the cofactors, so I'll do one of each. Plus, minus, plus, minus, plus, minus, plus, minus. But you know, if you were to do the actuals, a lot of zeros, things will zero out. It will be really easy to do, right? But if you decided to use this, I should do one each. I should have did the shortcut on this because it's much quicker, but it's all good. I'm going to pick this row. So I'm going to pick 0, but 0 times anything is 0. No need to write that down. Minus 0 again. The only piece that will survive would be 2 minus lambda times, and if I clear the row and column, it's simply the product of those minus the product of those. That would be negative 1 minus lambda times 2 minus lambda minus 0. So there it is. So didn't miss much by not using the shortcut. It turns out to be the same. So my equation is 2 minus lambda into negative 1 minus lambda into 2 minus lambda equaling to 0. And that would be my characteristic equation. It's already factored. You could multiply it out if you wish and say, oh, you know what, that's really negative lambda cubed plus 5 lambda squared minus 2 lambda minus 8 equals 0. Whatever works. And the homework is right there. And if they say find the lambdas, you could factor each of those and go from there. That takes care of this section.